Alright, so today we're going to be doing a pretty in-depth review of our Science 9 unit right now, energy and power. So first, let's look at the equations. And I use a bit different variables from what the teachers use and what you guys might use. So just feel free to change the variables to whatever you like. So energy, kinetic, that's just kinetic energy equals 1/2 mass times velocity squared. Potential energy due to gravity, so gravitational potential energy equals mass times gravity times the height it is displaced. Potential energy of spring, so elastic potential energy equals 1/2 k spring constant times x. X is where how much is displaced squared. Power is going to equal change in energy, so this can be kinetic energy, can be potential energy, whatever, okay, over time in seconds. So finally, our mechanical energy is going to be kinetic energy plus any potential energy that is involved in the system. So I'm going to split this video into two parts. First, these really simple questions that just require 1 or 2 steps. After this, we're going to go on to the multiple question choices. Okay, so this first one here, 1,200 kilogram car has a velocity of 10 meters a second. What is its kinetic energy? Well, we know the equation for kinetic energy is just 1/2 mv squared. So always write out your equations that you're going to use. So our kinetic energy here, 1/2, our mass, 1,200 times velocity, 10. And we're going to get an answer of 60,000 joules. Alright, this question says a 5 kilogram object is at a height of 10 meters. What is its gravitational potential energy? Write down the equation. U of G equals mgh. So, first of all, what is our mass? 5. What is our gravity? Always going to be 9.8. And the height that is displaced is 10. So this is going to be 490 joules, and that's our answer. This question says a mass in a spring has a spring constant of 60 Newton over meters. It's initially stretched at 2 meters. What is its spring potential energy? So let's first write this down. U of S equals 1/2 kx squared. So our spring potential energy here is going to be our spring constant, that's 60 Newton meters, times our displacement, that's 2. Square that. This will come out to 120 joules. Okay, our last problem here. A 12 kilogram object goes from 3 meters to 10 meters in 4 seconds. What is its average power output? So this, we're going to call this kinetic energy because it doesn't say anything about this being from a height or going down or going up heights. So EK equals 1/2 mv squared. But in this case, we're trying to find the change in energy because power is calculated as change in energy over time. So what is our change in kinetic energy? It's going to be 1/2 m because mass is a constant, and this is going to be the part that changes, our velocity. Our going to be our velocity final squared minus our velocity initial squared as well. Let's just plug in our values. We have our kinetic energy equals 1/2, our mass is 12 kilograms, and our final velocity is 10 squared minus our initial velocity, which is 3 squared. So this is going to come out to 546 joules. Finally, to calculate the average power output, we just have to look at how much time it takes for this energy to happen. Power equals change in energy over time. So write that down. So our power here in this situation would be 546 over 4. This is going to be 136.5, and power is measured in watts. So really the key to these questions is to know what equations to use and what units to answer in. Energy, any type of energy is measured in joules. Power is just joules per second or watts. Velocity or speed, whatever the problem uses, is going to be measured in meters per second. Length or height or anything with distance is going to be meters. Spring constant is going to be Newton per meter, and mass is going to be in kilograms. Alright, so let's move on to a harder question. An 8 kilogram object is going down a frictionless hill, and it starts at the top of the hill, 10 meters, and the question is asking us to find the velocity at the bottom of the hill. Okay, so what does frictionless mean? Well, frictionless means that no energy is lost, so we're assuming 100% conservation here. We have an 8 kilogram object, which is initially displaced 10 meters, and it's about to roll down a frictionless hill. So first, what you have to do is find the potential energy of this. So we don't know what the energy is, but we know the mass is 8, we know the gravity is 9.8, and we know the height is at 10. This is going to be 748 joules of potential energy. And the reason we have to calculate this is we have to find out the kinetic energy at this point. And if we're assuming 100% conservation, the energy of this object at this point, even though it's kinetic, it's transformed from potential energy and it's 100% conserved, the kinetic energy should also be 784 joules. So we plug 784 into this equation. It's going to be 784 joules equals 1/2 of our mass, 8 our velocity times our velocity squared. So 784 equals 4 times v squared. So you just divide 4 by both sides. You get 196 equals v squared. You just root both sides. 14 meters per second as your velocity value. So this means that when the 8 kilogram object is at the bottom of the hill, the velocity would be 14 meters a second. So just to sum up what we've just talked about, if the question says it's going down a hill, a frictionless hill, which means this just means 100% conservation. So the energy at the start must equal the energy at the end. So that would be really critical when doing calculations. This problem, a 2 kilogram object is initially at a height of 5 meters. It rolls down a frictionless track, by the way, and takes 1 second to reach the ground with no friction. Find the mechanical energy at the top and the velocity, the change in mechanical energy, and the average power. So first of all, let's find the mechanical energy at the top. So we know that the mechanical energy equation is just any kinetic energy plus any potential energy. Right now, there is no kinetic energy because there is no velocity, but there is potential energy, that being potential energy due to gravity. So let's just write down an equation, mgh. So that would be 2 times 9.8 times our height is 598 joules. So in this kind of question, you have to recognize that energy at the top, there's only mass and there's only height, but there is no speed. It is completely at rest. So that's why we will only calculate the gravitational potential energy, all right? Now, let's find the final velocity. Same thing. We have to plug 98 joules into our kinetic energy equation because we're assuming here 100% conservation because there is no energy loss due to friction or air resistance or any kind. So v is our unknown variable here. So we have 98 equals, this is just going to cancel out because 1/2 of 2 is just 1. So we have 98 equals v squared. We're going to root both sides. We have an answer of 9.9 meters per second. Find the change in mechanical energy. It's this equation, obviously. Mechanical energy final minus mechanical energy initial. So since our final mechanical energy is purely kinetic, 98, and our initial mechanical energy, which is purely potential as well, is also 98, these are just going to cancel out and we're going to get a change in mechanical energy value of 0. Now finally, to find the average power output, we just have to look at the change in energy. Now, even though the change in mechanical energy is 0, it is still a conversion between potential energy and kinetic energy. So our change in energy would still be 98 and our time is just 1, giving us a final result of 98 watts. Alright, our last problem here, and probably the hardest. A 2 kilogram object is dropped from 10 meters of height where there's no air resistance. Find the total mechanical energy, the kinetic energy at 4 meters, the velocity at 4 meters, and the average power from the 10 meter to 4 meter mark if the time it took was 1.2 seconds. So first, let's find the total mechanical energy. Okay, so we know that the total mechanical energy just equals kinetic energy plus any potential energy. But since we're assuming 100% conservation, we're just going to take the point with this energy here, which is only potential energy, so we can just cancel out the kinetic energy. So we have our mechanical energy equals mgh, so it's going to be 2 times 9.8 times 10, and our answer is 196 joules. Now, the question is asking us for the kinetic energy at 4 meters. And to get this value, we have to recognize that at 4 meters, the question is giving us a height distance, which means that there is potential energy and kinetic energy, hence our mechanical energy. A really important note to make in this situation is that you have to recognize the total mechanical energy, 196 joules, is always going to be 196 joules no matter where you are in this point, okay? So let's just put in 196 joules as our total mechanical energy, plus our kinetic energy value, which we don't know, plus our gravitational potential energy. So we have 196 equals our kinetic energy, and let's actually calculate the gravitational potential energy, which we can because we have a height here. So it's 2 times 9.8 times 4, so 196 equals our kinetic energy, which we still don't know, and this is going to be 78.4 joules. And to get just kinetic energy alone, we just simply minus 78.4 on both sides, and we're going to get 117.6 joules equals our kinetic energy at 4 meters. To find the velocity at 4 meters, we have to just plug this into a kinetic energy equation. So we have 117.6 equals 1/2 m, which is just 2 times v squared. So I have 117.6 equals, this cancels out, v squared, root both sides, and we will get 10.84 meters per second as our velocity value at 4 meters. So to find the power in this situation, it's just how much energy is lost over time, and in this case, the potential energy. The key here is that our change in energy here is just how much GP is lost. So we have 2 times 9.8 times, this key here starts from 10 and 4, and then we have our time, which is 1.2 seconds. So our total average power output is going to be 98 watts. Yeah, that's our answer to this question. Alright, since this video is getting too long, I'm just going to end with some board problem tips. So if the problem gives a height, find the gravitational potential energy. And then, once it asks for the velocity at the end or something, set this UG value that you found to UG equals 1/2 mv squared, assuming 100% conservation, of course. The words start from rest, or like initially is rested, this just means their initial velocity is 0, so you just cancel that out when you're calculating changing kinetic energy. The words up, down, elevated, or any other synonyms, use the gravitational potential energy because that's synonymous with height. And if it doesn't have any of these other words or any of the synonyms, just use kinetic energy. So yeah, I hope this video helped you, and have a good day. Thank you.